Hey, this is Rob with Veracity. It's great that people are using the statement viewer, and I guess they find it pretty compelling. Looks like a lot of our clients, that's their only real window into their data is looking at the statement viewer. And that's cool because, we put a lot of work into the statement viewer. You can do some relatively interesting work with it. Yeah, there's a whole lot more to the data analytics features that we have. So there's a couple different ways you can get there. You can find sort of an actor or an object in the statement viewer and click the little graph icon. Or you can also just get to like the whole package by going to analytics. I'll dive in by going to kind of the graph icon. See how it says graphs for this object in the little pop-up there? I'll hit that. And what this is going to do is it's going to load the dashboard pages, but sort of configured for the object I just clicked, which was programming for everybody, which looks like a lesson. So this is what we call the activity dashboard. The activity dashboard shows different things depending on what the activity is and what data is available. But you know what? I'm going to come back to that. Let me just go to like the overview. There's a handful of different features and different dashboards you'll find on the left side here. You'll see I'm in the activity dashboard. I'm going to go to the LRS overview. The LRS overview is just kind of a window into all of the things that are happening with the entire database for this LRS. And of course, if you're organizing your data into separate LRSs for some reason, this is only the data in your one LRS, but it's all of the objects and all of the actors and all of the verbs and all of that stuff within that single LRS. So this is more of an overview of what's going on. It's of somewhat limited utility if you want to answer specific questions, but it's a great place to just get like a glance of what's recently happening. Before I talk about each of the different graphs on here, let me just show you around the user interface a little bit. There's a board on the side or a sidebar that kind of pops out. You can collapse that sidebar, and you'll notice that the graphs all reflow. The system is sized dynamically, so no one is going to get the exact same layout of graphs that I have on here. These graphs are always trying to kind of fit themselves as best they can into the available space. But if you find you'd like to get more stuff on the screen, you can collapse that sidebar out. Each of these kind of whitish cards, we call them widgets. Most widgets are graphs, but not every widget is a graph. Like this LRS overview is kind of a context card, and it's a widget, but it's not a graph. I think everything else on the LRS overview is a graph. The different types of dashboards are available in the sidebar. I won't go into too much of that. I'm just going to do kind of the basics today: activity overview, learner overview, LRS overview. There's also custom dashboards, but also there's the plugin dashboard, which is super cool, something I'll talk more about probably in the future. And as far as other navigation goes, so you get a drop down at the top here. This is where parameters that are relevant to the entire dashboard go. So you can pick kind of a time range. Pretty much everything in the system supports this global time range query. You'll see I get kind of a smaller data set here because I picked just 7 days. 90 days is the default. Some of the other dashboards, like the activity dashboard, they have other parameters that are required beyond just the time of day. I'll show you how to get to those. So yeah, let me go back to, sorry, I was looking for a LRS overview. There we go. A couple other user interface elements just in the dashboard generally is the little refresh button. So the way our system works, there's kind of a caching layer. We generally show you the same results if you kind of pull the dashboard back up within 5 minutes. And depending on the amount of compute time the analysis takes, sometimes those can be longer. Like if we decided that this analysis took half an hour, then when you come back to this page, we're not going to kick off a new half-hour process. We're going to show you the most recent one. You can force refresh, though, by hitting the refresh button. And most of those, you might not even have seen it on the screen share there. Pop by instantaneously. Some of them take longer to compute. It depends on what kind of server you're on and all of that, of course. This page doesn't show any, but I'll show you later. You may occasionally see at the bottom of the screen a little note that says 7 widgets are hidden. The system does its best to only show things that look like something. Like there's a lot of computations that for your particular data or in your time frame, there was just no relevant results. Imagine, we have a chart which is kind of like success versus failure. But for the time window you pick, there are no successes and no failures. That whole graph just disappears. It's just gone. You don't even see it, because we don't like to present dashboards that are full of kind of empty widgets. However, if you want to kind of refresh that because something just happened and you don't want to wait the 5-minute timeout, you can't hit the refresh button because it's been hidden. So you'll find a little note at the bottom that says, show hidden, and then you can get to the refresh button to refresh it. It's just kind of a nice little thing to be aware of. The other user interface element which is relevant is the export. So many, not all, but many of the widgets have the ability to export the data that went into it. So this is the result of the computation that got graphed, not the raw xAPI statements. The format of that is going to be different for every different graph. But some of you might find that to be useful to export that data. What is possibly more interesting is the ability to export an image. You can hit this this thing, go to image, and then get a JPEG image or a GIF or whatever. And you can just download the JPEG file. Finally, if you want to do a live embedding of the widget, so we allow you to export these things to kind of iframe into your own dashboards or whatever. You hit the little link icon. We don't just give you links every time you click this icon, because the idea is you're kind of publishing this chart. That link gets a public UUID here. And so this is like relatively private because you have to know what this is. But anybody who kind of sees the link can then pull up the chart. And the intention is to put it in an iframe. So we even give you a little iframe window here where you can copy and paste the code onto a blog or something so that you can embed the chart. And what that's going to do is it's just going to put this exact graph inside of like whatever HTML that you put that iframe in. That is a very compelling feature for people. Something that's possible now, you can like create the exportable UUID via the API, because obviously going in here with the user interface is one thing, but if you're trying to do some kind of serious integration, you're not going to have a human go click these buttons, right? So this is now available. This feature is now available through the API. You can kind of say, I want this chart with these parameters exported, and the system will give you back the UUID, right? So that your system can sort of manage the database of exported charts. Currently, the API is the only way to un-export a chart as well. This is something to be aware of. Now, if a given chart in the exact configuration it's in right now, right, including the 90 days, if I change this to 7 days, it's going to be a different configuration. But if it already has a publish link in the exact configuration it's in, you won't get that "do you want to get a link" button. It'll just pop up what the current link is. So that's the basics of the user interface of this. Let's look at some of the data that we get, and then we'll dive in and look at something relatively interesting. Activity over time, pretty straightforward, right? This is the just absolute total chart of what's going on with the database. In a real one, then this is all fake data. We've got a couple of big real installations, and you can see the very clear and obvious kind of weekends on there, right? You can pan and zoom this thing by moving this little chart around. So yeah, so you can zoom in on a particular time frame by doing this. Realistically, it's a much better solution to use the global time drop down if you want to zoom in on a particular time. I mean, this is quick, right? But it doesn't change the whole dashboard. It just changes this one graphic. But that's up there. I mean, it's cool. You get a little minus button to go back to kind of view all. This same visualization gets more useful as the data gets restricted to certain people or certain objects, right? We have a overall view of which xAPI identities, which actors are doing the most things. Just total stack of all their activity, right? Not pass, not fail, not any particular verb or event or object, just most activity. So in this one, Susie is much more active than the next person down, who is Velma at 50. So, and this database has hundreds of people in it, but these are the top, well, there are like 12 or 15 of them here, 10. So something to watch for is the vertical axis of all of our charts generally kind of auto fits. So the bottom is not always 0. And that can be a little bit confusing sometimes. So something to watch out for. We've also got active objects. This is kind of the same thing. This is just presented as a pie chart, but the idea is the same. It's which xAPI objects are most frequently displayed or used in this time frame. This is interesting because there is a data modeling topic that's important, which is this wouldn't show if you had xAPI objects that were like questions on a quiz, right? There's a proper way in xAPI to kind of show that parent-child relationship. If the quiz has 1,000,000 questions, right, you would expect the quiz maybe to be the most accessed thing. But it wouldn't show on this one because the quiz isn't an independent object, right? It's really just a parent of objects. So this is just a breakdown of individual xAPI objects. If you're looking for the most recent parents, right, that have a lot of activity within some of their children, we've got a graph for that. Check out most active grouping contexts. xAPI gives you actually 4 different mechanisms to specify that some event happened inside of this other object, right? Like a question got answered within a quiz, or a quiz got passed within a lesson, or a lesson got terminated within a course, right? All of those are different ways that that the data can report itself as a parent-child relationship. In this case, data science reports itself as a parent using the grouping key. So there's 4 different types of parents. I won't go into all of that. It's up to the user as to like how they model the data and what they use the different kind of parent types for. In this case, our sample generator uses grouping parents to say that like there's lots of lessons within the course data science. And you'll see here, data science is the most active course, the most active grouping concept, even though it's not the most active object, right? Because it's not an object. It's a group of objects. I think you'll find in general, as you kind of, and this is something I encourage everybody to do, get better at modeling your xAPI data, right? If you don't tell us that the question was part of the quiz, then we can't tell you that the quiz is a very popular piece of content. We can only tell you about the questions. We need to know those things. So that's pretty relevant. These most active parent contexts and most active grouping contexts are like a roll-up of which parents are most active. We also got high scoring and low scoring objects. Not every xAPI statement reports a score, but when they do, we take the average over the time frame, and that's what we're showing you here. We don't show at all objects where we've never seen a single score. You will note, this is the average. So if you've got 5,000 statements about an object and one of them reports a score, and that score is 100%, it's going to be the top score, right? Because the average of 1 and 100 is 100. It's going to be the highest scoring, even though it's got relatively low traffic. So that's just something to kind of be aware of. We also show you the low scoring objects, programming language part B. So it might be relevant for you to know in this time frame, the worst performing object, right? The course with the lowest score, or course or question or whatever it is that you're modeling with your xAPI data. The one with the lowest score is programming language part B. It's important to understand that all of this is backed by the xAPI specification very explicitly, right? If you were to make up an extension or something that you called score, this graph isn't going to know about that, right? The specification has a place for score. That's where we get this data. If you needed to do things like show me the lowest scoring objects where the concept of scoring is not the specification's scoring field, but this field I invented in extensions, you'll have to use a custom dashboard. And that is not something I'm going to talk about right now. We also have a couple other things that you can look at. We've got verb type. So I'm pretty sure most people listening to this are going to know that xAPI does this subject verb object structure. And these are just, which verbs are most popular, right? And again, this isn't every verb we've seen. It's the top 10 or 12 verbs. There may be, in a database of thousands or tens of thousands or hundreds of millions of statements, there might be one or two statements that have some unique verb. It's not going to be on this list. We only show the top couple. And authority is relevant also. If you're using multiple keys to manage which data sources can write to your database, which you should be using, right? You shouldn't be, giving everybody the same API key. This will show you which of those API keys is generating the most data. That can be pretty relevant, especially if you are, imagine that you're looking at all of the performance of data science, but you happen to know that you gave different keys to several different institutions that are running your courses, right? Let's just say you published learning program, deep learning, data science. You publish all these courses. You might want to see, hey, look, well, let's go with Winterfell. University of Winterfell is, doing 85% of all the traffic on my database. That's good to know, right? I mean, you would probably want to know that. That's one reason that that you would want to make sure that you give separate keys to separate institutions or separate whatever, however you want to organize that, because, well, we can slice the data based on that and tell you. In this case, we use the sample generator. So 100% of our data sort of came from the sample generator, and we call that thing veracity-generated. So there's one other thing that is really, really super relevant, which is, this is the overview dashboard. Many, but not all of these things can be kind of clicked through to get to more specific dashboards. Because we have a dashboard for actors and we have a dashboard for objects, or activities is generally what objects are called in xAPI. Most things that are showing you an object, like this is machine learning, that's a thing, can be clicked through to get to the machine learning dashboard. So I'll click on that and it pops up. Now you'll see I've moved from LRS Overview to Activity Overview. I'm on the activity dashboard now, and you'll see the section that has the pickers, like the time picker, has a new picker, the activity picker. Basically, the clicking just kind of routes you to this dashboard and pre-fills that parameter. Activity dashboard is a little bit smarter in some ways than the LRS Overview dashboard, because it will attempt to show you graphs based on the type of activity as defined by the xAPI. So, xAPI has this concept of the activity definition type. This one is lesson. Now, we don't actually do anything special for lesson, but I'm going to go back and show you an activity that we do something special for. This is pretty much the default. So everything on here is the graphs we show for just any activity. We show you the verbs on that activity. So this is similar to the verbs overall, but now it's restricted to just this activity. Same with the time. You'll note that this one doesn't have any events before February, but the other database had a lot of activity at other time ranges, right? So maybe this was kind of allowed at a particular time. A bunch of students were allowed to enroll. Or this is the activity over time for just this object. We also have score over time for this object. We don't give you score over time on the other LRS Overview dashboard because it doesn't mean much to average the scores from different objects, right? But here you can see, hey, look at this. Actually, on March 4, people did significantly better in general than they usually do. So that's kind of interesting, right? What happened here? Now, what we don't know is we don't know how many people there were. It could be that, well, usually there's a bunch of people. And at this particular point in time, there were fewer people, but maybe there's one person, but they did better, right? So this is just the average over time of the score, and whatever that means. Also, actors with the most events. Of course, all of this is to the last 90 days, right? Actors with most events, right? You'll see here. This is interesting. See how this goes down to 0? And Susie Nomi, okay, has 1. That just kind of gives you a sense that, oh, there must not be tens of thousands of different students doing stuff on this activity in this time range, right? Otherwise, something as 1 wouldn't show up in the top 10, right? Success versus failure, everybody failed. And again, this is very important to note. The xAPI, it has a place where you say, was this event successful, right? And I want to be very clear. This graph uses the result success field. It does not count verbs of type fail or verbs of type past if you're using those verbs. Those things would appear over here in the verb breakdown. Oh, where is the verb breakdown? Up here in the verb breakdown. Something that you do see is the response breakdown. So there is a place in the spec for responses. And here we can see all of them have the exact same distribution. This is too easy. This is confusing. I don't understand. Good stuff. And can we go over this in class? Those are the available responses for this object, and they all have equal distribution. If this were a question, then you could very quickly look and just see, oh, everyone's picking A, everyone's picking B. I want to encourage everybody who might be listening to this to use the result response field to model that stuff. Again, I see people out there making extensions to store what the student responded. There's a place in the spec, and we use it. So if you want to get great graphs and you want to get meaningful insights in your data from our dashboards, you're going to have to put the data in the place where we expect it. And generally, we expect it where I believe where it's supposed to be. So for responses, it's in statement.result.response. Similar for completion. There's a success.completion. And this graph just shows you the ratio of true versus false for those. So I said that this was kind of the default dashboard for all objects, and that is true. Now, if your objects don't ever record a score, this just won't be here. If they don't ever have responses, then this just won't be here. Some objects are more interesting. Let's go back to the LRS overview, and I will show you grouping contexts. So when I click on data science, this is going to bring me to the same activity dashboard. But because data science, like I mentioned earlier, is a course, not a lesson, it's got children. And because it's got children, we end up showing all kinds of different things. You'll see that this looks very different, right? These are all of the objects in context. These are all of the different objects that report themselves as children, sliced up by how active they were in this time frame. So just looking at this, for all of the objects in the data science course, our programming was the one that was kind of had the most events in this time frame. Context activity over time is pretty relevant, right? This is the activity over time for all of the child objects summed up. Again, if this object were not a course but a quiz with questions in it, right? I mean, who cares about the activity over time of a single question? You're interested in the activity over time for the quiz. This would give you that. High scoring objects and low scoring objects, in this case, we modeled this as lessons that have scores and they're in courses, but the identical data structures could be used to do a very nice visualization of and a very nice model of questions on an exam, or even sort of assignments in a session or something, right? So this gives us the top score, bottom score. We also have the scores over time for the children. This gets a little bit busy. Generally when we have these legends, you can click off things to see just like one versus another. So these are all the different children, and you can compare and contrast the score over time for all of the child objects. Because this is a SCORM course, we get a couple of really special graphs here. This wouldn't appear for just any object that has children. This only appears for objects that have children that use the SCORM profiles session mechanism. One of the things in xAPI that is really important that I think that everyone should understand and do more often than we see is give us the database, give us some information about this statement was part of this session on the content. We can't intuit that stuff automatically. I mean, we could guess, but we'd never get it right for everybody. It'd be wrong for so we don't guess. But the specification has a couple of different mechanisms for you to say this statement is part of this group of statements, right? And as soon as you give us that grouping information, we can start to show you paths. This is a visualization of how do people flow from one lesson to another, right? So all the lessons are these, our programming, data science toolbox, all that stuff, right? This is showing us how people flow through the lessons. Because this course isn't actually linear, it doesn't really enforce any structure. You'll see there's not a lot to see here, right? But in general, the idea behind this graph is people who start statistical inference, you can just look at this and kind of see, oh yeah, it's about one third, one third, one third. So people whose first session is on statistical inference, one third of them move on to data science toolbox. One third of them take statistical inference again. That's interesting, right? And another third, where'd it go? Another third of them go down here to, looks like, data science capstone. So that actually, this little pattern might be relevant. Now, this is randomly generated, so it's not all that interesting. But even still, you can kind of see, oh, this is interesting, right? One third of my students start off in this one course and then go right to the capstone. And you can also see, now this is especially interesting, about the same percentage of people sort of exit the flow at that stage. Now, we don't know that those are the same people. We do know that about 75% of people go from capstone on to reproducible research. And that some 25% of people who take the capstone as a second module drop off. We could click in on this and see, well, did they pass? Did they fail? I don't know. Why are they dropping off? You'd have to drill down and see. But again, this can only be visualized if we have session information. And the vast majority of our customers are not giving us that information, which is a shame. Child outflow is very similar. You'll see that this graph looks like almost nothing. It's called the chord diagram, and it just shows you the summation of all of the different lessons. Where do people go next? In a course that is structured, where you kind of have to go from one to the next, you'd see just a big solid bar leapfrogging from one to the next, right? Getting thinner each time as people drop off. This really is a reflection of the branching opportunities in the content and what decisions people make at those branch points. But this doesn't show any pattern at all because it's random. We can take the same path information. Again, this one only appears if we have the same path information based on the session. We can tell you what the last thing people do is within one of these sessions, right? Basically what we do is we take all the events and we group them up by session, and then we sort them by their timestamps, and then we take off the last thing and we say, most sessions end on developing data products, right? So that could be very relevant if you're trying to find where are people abandoning my courseware, right? People are giving up, or ideally, 100% of session termination, right, would terminate at the last thing. But if you're looking at this graph and you're seeing that actually, no, there are terminations, there are people just done with my content that didn't get to the end, you might want to go back and figure out what happened there. Was it too hard? Was it too easy? Did they quit? Are they in progress? Do they plan to come back? That's not something we would know, but it's worth looking at. So this is pretty relevant. Again, it requires the pathing information. We can also give you variability of child scores. This is very similar to average child scores, but we also give you this vertical axis that shows you the standard deviation. Because we use a random number generator, you'll notice that these things all look pretty similar. But you guys know standard deviation. If people generally all get the same score, the vertical line will be very small, right? If scores are all over the place, the vertical line would be very tall. And this is plotting one standard deviation. And then we have activity over time by child objects. We have activity on this parent context, right, by student, and then stacked up by event type. And that's it for this dashboard. Let me show you. So that's just that's the activity dashboard. If you have activities that are video profile, you'll get some video profile events. The activity dashboard, in this case, we're showing the activity dashboard for this video, right? The activity dashboard is dynamic, and it will show you visualizations for video profile stuff if you have video profile data. In this case, we have this cool video histogram showing us where people are watching the video and the percentage viewed. And we're able to kind of pull this stuff up because our system kind of understands the video profile. It's got a little bit of logic in there to say, did this thing report itself as the activity type video, right? And does the data obey a couple of other rules that the video profile sets down? If it does, then we can pull out some information, like what's the video progress, how many views of the video have there been. This is like a little bit more semantically meaningful than how many statements are there with the verb view, right? Like the profile tells us that means something. It's not just a list of statements, it's views. So we can say how many views? 12 views. How much progress? 8.5% progress, right? The video histogram is super cool. This shows us like, look, no one has watched the end of this video yet. This is a fairly limited data source, though. I'm sure that's probably not true. But that's a good example of how the activity dashboard is dynamic. It just shows stuff based on what's available and what we know about the object. There are other types. If it reported itself as an assessment, you would get like a breakdown of all the child questions as like a stacked bar chart, that kind of thing. And then we have the learner overview. The learner overview is relatively simple, right? Okay, and I've got to pick a learner. So hey, this is relevant too. When you go to a dashboard that has required parameters and you haven't clicked on something that pre-fills them for you, either the graph button in the statement viewer or you've clicked on a pie wedge or something that brings you here, it will ask you to use the picker to pick something. I'm going to flip back over to the proper demo database. So you get to the same place. If you click on graph button on a actor in the statement viewer, you get to the same thing, right? You're going to be in the learner overview page, dashboard, pre-populated for that person. Now, we show you the 50 most active people in here, but you can also do like a full text search. So I see there's somebody, Ada. Let's do ADA. And it looks like she's the only person with that, right? This uses a full text index, so you can't do like partial words in here. You can do syllables, The actor dashboard is relatively simple because actors don't differ as much. I mean, widgets that don't show anything would be hidden, right? As they always are. But otherwise, you wouldn't see different graphs because this person has something about them that makes them different. Because there are no agent extensions in xAPI. Now, we might in the future develop our own sort of learner profile concept and then make some decisions about graphs based on that. One of the things that is really interesting, though, is this learner event over time by object turns out to be a pretty cool way to see the length of these people's sessions, right? So look, on April 29, you can see pretty much, just April 29, this person took what was it? Data Science Capstone. And here you can see the kind of the beginning and the end of their activity on Algorithms Part 1 and getting and cleaning data. And then look at this. So like, it looks like they've just spent forever doing reproducible research, right? In fact, if we look carefully, we'll see that they actually have a little bit of activity in early March and then a long series of nothing until they had some activity in April 27, right? But this graph is pretty cool. It just shows you sort of blocks of where people are doing what. It's almost like a Gantt chart for that one person. And then we just have a statement viewer. The statement viewer just gives us all of this person's statements. It's similar to the statement viewer that is built into like the main pages for the LRS, but simpler. It doesn't have its own sort or anything. It does have pagination, though. So that's the learner one, right? Let's save the whole custom dashboards for another day.